Real quick for this again, just to review what we were just talking about. This symbol right here, ABC, is just denoting the angle B. So it's if I have multiple triangles, and I had let's call that one B, A, B, C, D. At least we would know now in these instances that this is specifically the angle. Oh, I'm actually draw right on this thing. Let's go this way here. A, B, C, D. So angle ABC is just denoting that specific angle right there. Because we're starting and going to C. When it comes to triangles and shapes and all that kind of stuff, the other phrase we were just talking about is congruency. So congruent sometimes is mentioned as isometric, and if you want something to help understand it, we will use the term identical. And next to that is basically similar, okay? And the best way to describe similar is proportional. And if you need to do like a diagram next to it, the congruency can talk about like lengths or triangles themselves. But when I say identical, what I mean is like they would literally be identical in every way. Lengths, angles would all be the same. Whereas the proportional triangles, all the angles are going to be the same, right? But these side lengths over here may be different proportions. So you can even write in like 1, 2, 3. 1, 2, 3 as a side length. 1, 2, 3 as a side length. 2, 4, 6 as a side length. So congruent, isometric, similar, proportional. Those are your angles. The other thing I might, yeah.
Can you repeat what you said for similar?
So similar is proportional, meaning that all angles are the same, but like doesn't necessarily mean like it wouldn't mean that all side lengths are the same. It would mean that it is proportionally bigger or smaller, right? So as I was saying here, this guy here, if his side length was 1, that was 2, and that was 3, then over here it would be 2, 4, and 6. Like everything grew. This is like twice as large as this guy here. It doesn't have to be twice. It could be 1.727272, something really weird, right? But those are just phrases that generally we need to know for this stuff here, and then we'll get into these in more detail with some of the theories later on. But as a reminder, just up top here, let's talk about 2 other things, and that would be all straight lines add up to what as an angle? What would the measurement of a straight line be?
180.
180, right? Right? All triangles, if you were to add, right, all 3 of these right here up together, what would they equal?
180 degrees.
180. All angles add up to 180 degrees for any triangle. Whether it's a obtuse angle in there or not, they all add up to 180. Okay? That's going to be important because if I had this angle is 40 and this angle is 60, that would make this guy 80. If you have 2, you technically have 3. Okay, so it's just valuable information to know for triangles that when I add these guys up, these ones here, I'll add up to 180. Okay, so from there, let's kind of get into these angles here. You'll see that it's kind of identified what we talked about, angle EGB, but we kind of talked about it further. We're going to put diagrams next to this to maybe help it make more sense, because you can go up and look at the diagram itself to see, okay, angle EGB and AGH are vertically opposite from each other, but I think it's nice to put like just a small diagram next to this to describe what the heck that even means. So we're going to walk through this diagram right here, and knowing that these guys are parallel lines, there's going to be some rules that follow here, okay? The terminology itself is not necessarily super important, okay? But knowing that when you see something like that, will you be able to piece things together is going to be the more important part, So vertically opposite, what are they talking about? We're talking about these two guys here, right? That angle and that angle have to be the same. When two lines intersect, right, these two angles will be the same. Heck, these two angles will be the same too, right? So in terms of a diagram, right, just draw that. That's going to let you know that this is a vertically opposite angle. And that those would be the same. You can use this to identify things. We'll look at one example after this. Okay? Corresponding. Now, again, if you were to read through this guy, corresponding angles formed by a transversal cutting it. Oh my god, I'm already asleep. What are they talking about here is that if I have two parallel lines right here, okay? So that guy's parallel to that guy right there. If a line cut through two parallel lines, the corresponding angles that they are talking about are this guy here and that guy there. Makes sense, right? They're parallel to each other. So if I have a straight line that does not bend and it cuts through two parallel, those two guys would be the same thing. The technical term for that is just a corresponding angle. Okay? And when they say corresponding, they're basically referencing the fact that A, we're dealing with parallel lines, and B, we're also dealing with angles that are exactly the same. So if I knew one, I know the other. Now, this looks more scary than it is, but it's basically just explaining itself. Okay? We have corresponding alternate interior. Wow. Again, these two guys have to be parallel. And what they're suggesting is that this guy and this guy have to be the same. They are on the inside of the parallel lines. They're corresponding because parallel lines are involved and they are the same angle. They are congruent to one another. Samesies. Okay? Corresponding alternate exterior. Ooh. Same thing. Two parallel lines. Okay? Being cut. The alternate exterior is talking about that guy and that guy there. Outside of the parallel lines. Corresponding in that they are the same. Right? Now, underneath this is just kind of breaking down that supplementary angles add up to 180. All they're suggesting there, if I have a straight line, I know it's 180, right? Meaning, if I knew I had a straight line and I knew that this angle here was 40 degrees, what would that make this guy here? 140. Supplementary just means I know straight lines are 180. So if I have just one angle, I have the guy opposite of it. He's supplementary. Okay? Now, complementary is not what you think. It's not commenting on your fit during the day, your flow, or anything of that nature. I'll move on. Okay.
I guess we would get many of those.
What?
I guess we would get many of those.
There you go. I said this. That's all I wanted. Okay. Complementary means that if you saw that it was a right angle, and they said this guy is 30 degrees right here, well, then I would know that the remaining part there is 60. Right? The scalene, isosceles, equilateral. If you don't know what those three words mean, there's the door. Right? Pretty standard. Right? But that's basically it in a nutshell. So applying this logic, the only thing I would change on this guy here is he should be changed to HCI. And let's just ignore this guy for right now. All I want you to do is go ahead and try that one right there. I'm going to pause this, let you guys give it a shot. All they're suggesting is put in the angles in the places that you see and solve the remaining values that are there. Really and truly, all I want you to do is just put in that, like, knowing that he's 54 and knowing that BCF is 67. Okay. If we're aware of these things here, all I would like you to do is kind of just walk through and highlight, like, what can I solve for with what I have? We can go through and fill in what we can find anyway, but what's kind of neat about this guy right here is, well, if I know he's 54, then I know this guy here is 54 because vertically opposite, right? Meaning I would also know that this guy here is 54 because that's a corresponding one with this guy right here because it told me that DE and GF are parallel to one another, okay? Right now, if you want, because we knew those are corresponding, what other line can you figure out at this point? Or what other angle, sorry, can you figure out knowing what you know about supplementary angles,
67.
right? So if I go, yeah,
So it's the opposite of 67.
well, 180 minus 54 minus 67 is going to give me 59. So that means I know him because that's a 180. Okay, let's just say you didn't see that. I'm just going to erase this for a second. Okay, let's just say like I couldn't see that when I was looking at it. Fine. There's other skill sets here we can use. If he's 67, this guy's 67 because that's corresponding. If he's 67, that makes this guy 67. Heck, even if you didn't even see that first one that I did, if you remembered alternate interior angles, if he's 67, this guy is 67 because those two are the same. There's just little tricks like that where it just should be second nature. Now, instead of doing the supplementary angles, I know triangles add up to 180. So 180 minus 54 minus 67 still gives me 59. And then I could do the supplementary to get this guy if I didn't already see that these are alternate interior or that those are corresponding, right? Which means if he's 59, that this guy here is 59. What is it we were looking for? We needed to find angle ABC. That one is 67. KBE. We didn't get that guy yet, but we know it's 67 because it's opposite that guy there. And then HCI is just 59. Will you have a question like this on the exam? No. Will it be part of a larger long answer question when it comes to big triangles? Yes, it will. Right? Little things like that are going to come in handy. So, not super important, but something you should know. All right, let's talk about these guys here. I would like this to really solidify, hopefully, in your knowledge. So if you want to put up here, this is identical measurements. These guys are identical. And what I want you to put next to it here is, when will you see this? I like to kind of give you an idea of what would you be using this for? How will you be assessed on this guy? The only way you'll be assessed with this one is prove it. Prove that one triangle is identical to another. There's theories we can use. Prove it via 3 theories, right? So these are identical. You'll be given a triangle in likely multiple choice. There will be 4 beneath it. They will say which one of the ones below is congruent to this guy here. That is highly likely a question that will be on your exam. Okay? So, first theory that we can use. Let's just kind of do like a little dive into triangles themselves. Okay? If I have all 3 sides, I know everything I need to know about a triangle, right? That's helpful to know, right? These dashes indicate that this guy pairs with that one there and is the same as it. This dash and this dash here, those guys are paired together and would identify that those guys are the same measurement, that those measurements are congruent to one another. Because all 3 sides have exact matches, congruent matches, then we can say, yes, these are isometric or congruent based on the theory of side, side, side. That's really all these guys are. This is the one you can kind of ignore because obviously, if all the numbers were the same, then it would be the same. So are they going to use this one to test you? No, it's just too easy. There's not even any like skill set to it. So you have to know that it exists there, but it's not the one that's going to prove to you the right answer. It'll be one of these two guys. And all that I want you to put is that the order that this appears matters. Here's why. Let's just talk about triangles for a second. So if I have a triangle right there, okay? If I knew this side length is 5 and this side length here is 6, but I didn't know what this guy was here. However, I did have its angle. That would be super helpful, and I would know everything I need to know about the triangle because all 3 sides are covered. What do I mean by that? All 3 sides are covered. Know him, this angle has a relationship with that side length. What do I mean by that? I mean, if this angle here got bigger, right? If it got bigger, the side length would get bigger, right? Than this guy right here. If this angle got smaller, let's just say, that side length would get smaller. They have a relationship with one another. That angles opposite side lengths are paired, okay? All that to say, in this case here, right, you need to have both in order. It has to be that this guy is side, angle, side, and that this guy is in side, angle, side order. If they are not in the same order, then it doesn't flow. And because I'm recording, I won't suggest what I normally do, but you can maybe remind yourself using some sort of like mnemonic device here. It needs to be SAS, and then you can reorganize the letters in another way that it shouldn't be. And it is a phrase that I usually assign to other members of the grade 11 class. There you go. So it's got to be in a specific order in this case, and if it's not, it doesn't work. And that also applies to the next guy here. Why is that? Because this guy tells me everything I need to know about the length EF. This angle tells me as much as I need to know about side length DF, and then I have that length, so I don't need really to go much further with it. But it needs to be in that order because every side has to be covered. And both would have to be that way. Where this may get like a touch challenging would be something along the lines of this. So if you want an example of this guy here in terms of where it might be a little bit challenging is, and this would apply to this guy here as well. But if I had this side length here is 5 and that side length there is 5, and I knew that this guy here was 60, and I knew this guy here was 70. And I'm like, sweet. I've got angle, side, angle. That's in perfect order. But on this next guy down here, I've got 60 and 50. And they're asking you to prove these guys here. I'm telling you right now that those are congruent. What would you have to do to actually prove it in this case? Find the remaining angle. I would do 180 minus 60 minus 50. That would tell me that this guy is 70. Now all of a sudden I have angle, side, angle in order, and then you could verify that those guys are actually the same thing. Okay? So I'll have you take a look at these ones down here in terms of just as examples, right? Are these triangles congruent? Yes, they are, side, side, side. No, they're not, because both of them are out of order, the second one. Let's take a look at number 3 and number 4, right? In fact, if you want to add this here, since angle is not between sides, out of order. What about number 3? What do they mean side, angle, side? I don't see the angle. Where's the angle there? What's happening? There's no little hash mark denoting that the angles are the same. But they are vertically opposite. This is why these are the little things that you'll need to know, right? Knowing that they're vertically opposite, so this, right, you want to write it in, vertically opposite, right? And this one down here, angle. Wait a minute, there's nothing mentioning that those side lengths are the same except for these are a shared side. If it's a shared side, it's obviously the same thing, right? So just add those in as just little explainers to kind of help assist in your understanding of this. But these are talking about congruent and isometric. So these first two questions are asking you to create isometric triangles. So what would you have to add to this to make it isometric using side angle side as the theory? What would you need to add to this guy to make them isometric using angle side angle? And then explain why the ones below are not. And that's as far as we'll go with that guy there. I'll run through this quick in a second. Again, this stuff is not, I would say, hard. It's just information we need to know. If I'm saying SAS, I would just need to add those two side lengths there. That would basically be it. If I said SAS, I would just need to add two angles in there and there. And then same thing with this guy here. As long as it's being bracketed properly, then that's all I care about, right? In these guys. Questions on that? Pretty simple. What would be missing for angle side angle? Well, it's got to be in order. So there's an angle, there's a side length, so then this guy would have to be an added angle. There's an angle, there's a side length, so then this one would have to be an added angle. Okay? This one here already has two angles, so I know the side lengths, got to go in between the angles, right? Even if they're flipped around, it doesn't matter, right? You're just looking for an order to it. So angle, side length, angle, angle, side length, angle, right? Explain why the triangles are not isometric in this case. Are not isometric, okay? So for these guys here, explain why they are not isometric. Okay. Well, here's what's funny about it. He's in order. I got a side length, I got an angle, I got a side length. This guy's good to go. Hey, look, all the numbers are the same, 7, 8, and 35. But angle, side length. Not in order, and as such, can't be used. Both of these guys are out of order. This one's just way off. It doesn't know what's going on, right? Even if you tried to logic it out and go 25, 12, 45, ooh, I can figure out what this guy is here. I can figure out what this guy is here. But it doesn't flow. Let's take a look at it. We know that the remaining 180 minus 45 minus 25. We know that the remaining for both of these guys is going to be 110. 110. Perfect. So even if you went that far and you did that little trick, I have angle, I have side length, I have angle, I have an angle, I have side length, I have angle. Why is this broken? Why does this not work?
Where the 12 is placed. Because
Say it.
different angle.
It's a different angle, right? It goes 110, 12, 25. Like 25, sorry, when we got 110, 12, 45, not 25. So as it is out of order, it can't fly. The trick I'll use for this guy here as well, if you want to make it easier on yourself, is once I've identified stuff like this, I'll start to place things out. So the first guy is 45, and then it goes 12, and then it goes 110. And then underneath, if I run through the same logic, I have the 110, I have the 12, but this guy is 25. If they all don't match, then you can basically just reject it on this guy right here. So it's just a simple little trick that we can use with that. Questions? Moving on. So this is more of an old school part of it. This is what you were asked of to do in the past. They've simplified it a little bit. You really just need to know when it's side angle side and give me some sort of explanation. But let's just look at this guy here as a further dive into why we would justify that something is congruent based on a theory. This statement is something you should know. What the heck does that mean right there? What is the hat on the AB? What do you think that means? Yeah, the line segment. So line segment AB is congruent with line segment EF, right? It's denoted here by the dashes, but the sack of pancakes with the whipped cream is telling me that these guys are congruent as well. Okay? Those angles, they're identifying that this guy and this guy are also the same thing. How do I know it's given? It's given in the diagram. The AC, EG, right? Same thing. Those two line segments are the same because they're given. And then at the end, they use this lovely guy to just explain. Triangle BAC is the same as triangle FEG based on that theory. Because I identified all three parts that I needed to. Okay? You don't have to go through this as crazy as in depth, but you do have to still prove that those things all exist. But the statement of justification is not as ugly as that anymore. Okay. So the similar triangle stuff here. Let's talk about this guy here at the top. So the other word we'll use for this is proportional. Let's use words that make sense. Now next to it, where are you going to see this on an exam? You're still going to be asked to potentially prove it. So option 1, prove it based on theories. Okay? It's a nice little O there. Okay? The other thing that you may be asked is to find missing sides. So that's where you'll see this guy. And it'll be short answer and or multiple choice. But
What is that before the find?
it's a 2. It's a 2. It's a 2. So on this guy here, those are my 3 theories. Let's just roll through them really quick. Side, side, side angle, angle. I no longer need angle, side, angle for proportional ones. Okay? And in fact, if they were going to get you to try and look through it, usually the angle might not be the one. Right? Sometimes it is, depending on how they present. But let's look at how I would probably set up and solve for something like this here. This does a good job of kind of showing what's going on. Right? But, just like I showed you before, I want you to set things up like this. Or set it up whatever way makes sense for your brain. There's different ways I've seen people do it. This is how my brain works, right? Big triangle goes on top, small triangle goes on the bottom. I've got side, side, side for this guy. I want to prove them. And I'm going to go large, medium, actually, on top of it here, large, medium, small. What do I mean by that? Let's just start with the first triangle. It's almost easier to do it this way. What's the largest side on this big guy? 7. What's the medium? 5.25. What's this guy? The smallest one, 3.5. Go over here. Largest, 4. Medium, 3. Smallest, 2. All right. What do I have to do with all that stuff? Well, I actually have to divide them. So 7 divided by 4 is going to give me 1.75. 5.25 divided by 3 is going to give me 1.75. 3.5 divided by 2, 1.75. Because all three are the same, then I'm good to go. Do you have to write out that guy in full that way? No. Whatever way makes more sense for your brain. Like I usually just now shorthand when you see me going forward, I'll just write SSS and then put the numbers over top of it. And then if it works out, like I'll just put like the 1.75, yes. Right?
So do they all have to equal the same?
They would all have to equal the same. If one of them was off, just one of them was off, then it's not a similar triangle. Because think about it. That is telling me proportions. Do you remember K factor last year? You found the K factor for, let's just say, a length, not area or volume, just say for length. When you found out what the K factor was, what were you actually doing? You were finding the proportion of it, of one to another. It's basically applying the same logic of if all proportions are similar, or not even similar, if all proportions are the same, then we can prove it is a similar triangle. Or that they are a similar triangle. Okay. So SAS, one congruent angle between two pairs of proportional sides. So the same logic is going to apply. I'm still going to write out ASA in this case. Or, sorry, not ASA. I'm still going to write out SAS. And then fill it in, right? 6, 4, 3, 2. 6 divided by 3 is 2. 4 divided by 2 is 2. They're both denoted with the same angle there. Good to go. Okay? But you still have to do the proportional ratio on the bracketing side lengths. Okay? An angle just goes without saying. Right? If I have 2, I have 3. So if I have 2 that are the same, then I know that the triangles are exactly the same. Meaning, where will this be tough? We already did one just before, but I'll do it again. 60, 70. This guy's bigger. We'll go 60, 50. Just do one of them, right? 180 minus 60 minus 50 gives me 70. He goes there. Now I can say angle, 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 angle. It's good to go. That's as complicated as it gets. Again, where will you see it? You'll see it basically in the land of prove that this guy is the same as this guy here. Anyway.
Well,
Mhm.
so if you have SAS and one triangle is bigger than the other, then if you have two sides that are the same, it means that like
Similar.
they're good.
Yeah.
So you don't have to do the angle.
If you had two sides and an angle that bracketed, yes. If you just have two angles, as long as you have two matching angles, you're fine. Because think about it. If I'll put it this way, if I have 2, I have 3, right? If I have 2 that are the same, I have 3 that are the same. Because if I know 2, I can get the other one. If they're proportionally the same, let's think about it. If I have knowledge of all 3 angles, so this guy here, this guy there, right? Then I know everything I need to know about that side, and that side. All 3 sides are covered. So as such, when I have 2, I have 3, meaning I know everything I need to know about the triangle.
So when you have side or angle, and when you have two angles, you don't need the side, you just need the third.
For similar, but let's go back up to the isometric, right? If I go back up to this guy here, right? For isometric, for the identical ones, the side length does matter in between 2 angles because it has to be exactly the same in every way.
Well, will they give you the side length?
Okay, so the question will be phrased as such. Which one of the following is congruent? So then you'll use side, 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 or angle, side, angle. If it says which one of the following is congruent to this one. If the question says which of the following is similar to this guy here, well, then I go to the theories side, 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 and just angle, angle. If you want to go back up to the first page here, right, and right underneath it, now that we know what we're talking about, where it says similar and congruent and all that stuff, what I would do is potentially outline or highlight or underline those words there, as that's how it will be denoted, and then write down the theories for congruent, right here. Write down the theories for similar right here, right? And then that way you can kind of remember, all right, there are a little bit of differences to it. This one, there's really no math to it. This one there is, because it's proportional, right? You got to do the division and things like that. So it might be a way to just organize your memory aid in that way. And I'll give you a document that hopefully assists with this stuff here and kind of goes into a bunch of the formulas. We'll modify it a bit. But I'll stop this for now because I think it's as far as I want to go.